Assalamualaikum and good day. The name that we had chosen for our group is ET. Our member consists of Natasha binti Hassan and Kantianila Rampa Anak Tedung. We are really grateful because we managed to complete this video presentation within the time given by our lecturer Sir Shafiq. This assignment is impossible to be done without the amazing cooperation and effort of our group members Kantianila and Natasha. We also sincerely thank our lecturer of Calculus I, Sir Shafiq, for the guidance and willingness to help us in what we are lacking when completing this assignment, and surely for teaching us this course. Last but not least, we would like to express our gratitude to our family members who keep on encouraging us all this time.
So our group has chosen related rate, also known as rate of change, for this assignment topic, which is applications of differentiation. For introduction, one of the applications of differentiation in the fundamental theorem of calculus is related rate, which also known as rate of change. Related rate normally involving figure out a rate of changing of a quantity from another quantity that is given sufficient information. Related rate is also known for its benefits in the application in life. For an example, we can figure out the speed of two vehicles that drive in different directions if each of the vehicle's speeds and direction is known.
Problem statement. A 20 feet long ladder rests against a house on a flat ground. The bottom is initially 7 feet long away from the house wall. The ladder is moving up when it is being pushed toward the wall at the rate of 1/5 feet per second. Calculate how fast the top of the ladder moving up the wall 10 seconds after we start pushing. The objective are to determine the rate of the top ladder moving up after pushing it, and to apply Pythagoras theorem formula in differentiation. So here is the illustrative image of the situation before. We can see the 20 feet ladder rests on the wall. At first, the bottom of the ladder, or we call as X, is 7 feet away from the wall. However, when we push it toward the wall at the rate of 1/5 feet per second, the value of X decreases, and here we want to find the rate of the top of the ladder, or we call as Y, moving up after 10 seconds.
For the first step, we can draw an appropriate figure and label quantity given related to the problem statement for better understanding. From the problem statement, we know that the bottom of the ladder is 7 feet away from the house wall. We also know that the ladder is moving up at a rate of 1/5 feet per second. Based on the question, it asks us how fast the top of the ladder is moving up, which is dy dt. So from the information given, we know that dx dt is 1/5 feet per second, and the question asks us to find dy dt. From the figure that we have drawn, we know that this question is related to the Pythagoras theorem. As we all know, the equation for Pythagoras theorem is a squared plus b squared equal to c squared. Therefore, we can substitute the information given into the equation and differentiate the equation. Next, we know that the bottom of the ladder is 7 feet away from the wall before it being pushed up. So we want to find the distance after it being pushed. Therefore, we substitute the informations of rate and time to find the distance after 10 seconds. After we calculate the distance, we get to know how long the bottom of the ladder from the wall after 10 seconds.
Next, since we already know the value of x, which is 5, we can find the value of y. We can use the Pythagoras theorem once again here in order to find the value of y. Substitute all of the known values into the Pythagoras theorem formula, and we will get y equal to square root 375. The last step is we use the equation that we got on step 2 before, which is 2y times dy over dt plus 2x times dx over dt equal to 0. Substitute all of the values we got earlier in order to find dy over dt. So here, we get dy over dt equal to 0.052 feet per second. So the conclusion is, the rate of the top of the ladder moving up the wall after pushing it is 0.052 feet per second. We can apply the Pythagoras theorem formula when solving any problem that involves finding an unknown side of a triangle.